Okay, everyone, assalamu alaikum. I hope you're all well. We'll be starting in a couple of minutes, inshallah. In today's session, we are doing March 2026 paper, March 2026 paper 1, 2 for Ad Maths. This is the plan for today. Okay, March 26 paper 1, 2. We will be solving this paper in full. If you want to join these sessions, these are free past paper sessions that I'm conducting for AdMaths. If you want to join, you can have a look at the link in the description. It's also pinned in the chat. You can join using that to get added to the WhatsApp group. The time for these sessions every day is going to be different. That's one main reason for having that WhatsApp group because it'll be different times every day, which I'll be communicating on the WhatsApp group. I'll also be telling which papers we are going to be doing on a particular day. I'll be communicating about that in the WhatsApp group as well. So if you want to join that, you can have a look at the link in the description or in the chat. Okay. All right. So we did November 25 paper 1 variant 2 yesterday. Today we're doing March 26. Tomorrow and the day after tomorrow, Saturday and Sunday, we will be doing difficult questions from around 5 to 6 papers from a number of 2025 papers. I'll be posting some polls in the WhatsApp group to decide which questions we want to do in those sessions. So you'll be letting me know the questions that you find difficult from a number of papers, and we will be discussing those difficult questions tomorrow and the day after tomorrow. Okay. So that's the plan. Share this with your friends as well who are taking AdMaths. Anyone can join. You can join using the link in the description. ठीक है, चलें, let's begin. P3, yes, P3 did get leaked. Those of you who are not in Pakistan and did give the P3 exam today for A levels, it did get leaked, unfortunately. So yeah. Let's see if whether Cambridge accepts that or not. Those of you who gave that exam, since it was cancelled it was postponed in Pakistan, make sure that you raise your voice because it will not be accepted by Cambridge unless you make some noise. Okay, so ask your friends, everyone you know who gave the paper to post on social media, to email British Council to make them accept this because otherwise, if a lot of people do not uh, complain about it, they tend not to accept any leaks, right? So like they did for A-level business paper, A-level accounting paper, IGCSE math paper. So make sure that you are raising your voice about it online and to their whatever is the institution that conducts these exams in your local in your country. Reach out to them, send them a lot of emails, ask your friends to reach out to them, email uh, Cambridge International as well. That is important. Otherwise, they will just ignore this. Okay, because a lot of the noise earlier was coming from Pakistani students. So if they did not take this exam, the outcry may not be as much. So make sure that you do play your part in that. ठीक है, चलें, let's start with this. March 26, paper 1, 2 for IGCSE Art Maths. It was a fairly easy paper, having looked at that. So unfortunately, all the easy papers are getting leaked. M1 apparently was relatively difficult. That's the only math paper that you have taken fairly until now. Chale, let's get started. March 26, paper 1, 2, just a disclaimer in the beginning. I I haven't I've actually just slept for a couple of hours, 2 hours in the last 30 hours. So I am very sleepy right now. So make sure that you are doing the calculations along with me and let me know if there is any careless error at any point. ठीक है, चलें, let's begin with this. March 26, paper 1, 2. This is IGCSE O-Level at Maths 40370606. We're doing this paper. अच्छा, A polynomial p, the first question, a polynomial p is given by p of x equals 4x cubed plus 8x squared minus x minus 2. We need to show that x plus 2 is a factor of p of x. Now, it's a linear divisor. It's a linear divisor x plus 2. Just give me a second. I'll adjust my pen sizes quickly. Okay. So it's a linear divisor. Since it's a linear divisor or linear factor, we can use remainder theorem or factor theorem, right? Let's do that. X plus 2. Let's put that equal to 0. What value of x do you get from that? Negative 2. All you have to do is you say remainder is going to equal p of negative 2. Input x equal to negative 2 and this, and that will give you the remainder. Let's see what this turns out to be. 4 into minus 2 whole cube plus 8 into minus 2 whole squared minus into minus 2 minus 2. Simplify this. Now, they are asking you to show something. So it's necessary that you show some working. So this step is absolutely necessary. If you skip this step, you don't get that 1 mark. You have to input the value in the polynomial. Now you can write 0 directly as well, but it's a good idea to show one more step at least. Minus 8 into 4, what will that be? Remember, calculator is not allowed, so you have to be careful with your calculations. Minus 32 plus 8 into 4, that will be plus 32. And then you have plus 2 minus 2, and that gives us 0. Since the remainder is 0, that shows you that x plus 2 is a factor. Okay, that's the first question, fairly straightforward. Now they're asking you to solve this equation, p of x equal to 0. When this polynomial is equal to 0, solve this cubic equation. How do we solve a cubic equation? We have a factor given. We can do long division to find the other factor, right? Let's do that. 4x cube plus 8x squared minus x minus 2. Let's do the long division. You can do long division, you can do synthetic division, any method will work. You can use coefficients comparing method. That will also work, right? So all of those methods will work. Let's do division. Divide this by x plus 2. What do we get? X into what will give us 4x cube? 4x squared. We multiply x by 4x squared to get 4x cube. Let's do that multiplication. This gives us 4x cube plus 2 into 4x squared, that is 8x squared. Okay. Now, what are we left with? We have minus here, minus here. This gets cancelled. This also gets cancelled. Now, that leaves us with negative x negative 2, minus x minus 2. What do we multiply x by to get minus x? We multiply it by minus 1. Multiplied by minus 1, and that gives you minus x minus 2. Change the signs again. This becomes plus plus. This gets cancelled, and we're left with 0 at the end. The remainder is 0. If the remainder is 0, that confirms that your working is correct because it was supposed to be a factor. If it's a factor, the remainder should have been 0. So we're getting 0 as a factor now, 0 as the remainder now. So what's the other factor? The other factor is this. You can write that polynomial equation, p of x equal to 0. You can write it in this form now. One factor was x plus 2 and the other factor is 4x squared minus 1. This equals 0. Equate each of them equal to 0 separately. X plus 2 equals 0. Or x squared minus 1 equals 0. 4x squared minus 1 equals 0. The first one gives us x equals negative 2 and the second one gives us x squared equals 1 over 4. And the value of x that we get from this, the two values of x that we get from this, they are plus minus 1 over 2. And these are the final solutions that we end up getting from this. That's our final answer. Is that okay? Makes sense to everyone? Okay. Actually, let me just connect my mic quickly. Voice quality is not very good. Just... Okay, can somebody please confirm if you can still hear me? Can Somebody please confirm if you can still hear me. Can you guys hear me still? Okay, chale. These are the values of x that we get. We have three solutions. It's a cubic equation. That's what we expected. X equals -2 or x equals plus minus 1 over 2. These are our final answers. All right, chale. Let's look at the next one now. Now they're saying on these axes, sketch the graph of this function. X squared minus 2x minus 3, state the intercepts with the coordinate axes. Now, how do we do that? It's a quadratic function and it has a modulus around it. It has a modulus around it. Now, what does the modulus function do? Whatever is below the x-axis, that is going to get reflected and come above the x-axis, right? So what you can do is you can first of all draw this quadratic function that is inside. How do you sketch that? There are some important points that you have for a quadratic function. You have the turning point and the x and y intercepts, right? So find the turning point and the x and y intercepts, and then you can sketch the graph after that. Okay, let's do that. What's the y-intercept? What's the y-intercept going to be? Of the original graph. So right now I'm just thinking of this graph first of all. X squared minus 2x minus 3. Let's think of this function first. Now what's the y-intercept for this? The y-intercept for this is -3. So we have one point on the graph that is at -3. Let's just mark it for now. We know it's going to be reflected later on. Let's just mark it. This is one point that we've got. What about the x-intercepts? What about the x-intercepts? We'll have to find them, right? Can we factorize this? We can write it as x squared minus 3x plus x minus 3. And then that becomes x plus 1 into x minus 3. These are the two factors that we get. Now, if you put y equal to 0 in this, what are the x values that you get? -1 and plus 3. So the x-intercepts that you would get would be -1, and you have 3 on the right side somewhere. Acha. Now, what about the turning point? What about the turning point of this function? Where is that going to be? They did not ask us to show the coordinates or show the turning point. Okay. But we know it's not that difficult to figure that out as well, right? Because this is -1, this is 3. The turning point of a quadratic function is always exactly between the two x-intercepts. It's going to be exactly between -1 and 3, right? Exactly between those two numbers. Okay. Now, that means it is going to be here at the point 1. It's going to be right here. Okay. It's going to be here, the turning point. Now we can input x equal to 1 in this and figure out what value of x we get from that as well. Let's do that. If we input x equal to 1 in this, or in this function, let's say, let's see what value of x we get from that. What value of y we get from that? X equals 1. That will become 2 into -2, which is -4. So at x equals 1, we get y equals -4. Now these are the points that we have got. Let's mark that here as well. So the original graph is going to look something like this. The original graph is going to look something like this. Without the modulus. Okay, without the modulus, the graph would be something like this. Take it. But we have a modulus around it. What does the modulus function do? It makes anything that is below the x-axis, it makes it positive, right? It comes up above the x-axis. So this part that I've drawn and drawn dotted there, what happens to that part is it comes above the x-axis. So now that point at -3, that is going to come here at +3. The turning point is going to be at the point 1 and 4. And the graph is going to look like this. It's going to be this and this. And then you can remove that dotted part. We don't need that. Let's just get rid of that part. That's the graph that we wanted to sketch. That's our final answer. Okay. So we had to show the intercepts. We had to show the intercepts. The x-intercepts are -1 and 3. The x-intercepts are -1 and 3. And the y-intercept is +3. The original turning point of the quadratic function was 1 and -4. When that gets reflected, the y coordinate becomes positive. It comes here. So that's the turning point. It comes at this point. Okay. How is y -4? Let me just check my working again. I just put 1 in this function. When I put 1 in that function, we get 1 minus 2 into 1 minus 3, and that is -4, right? Now, when we put modulus on that, that will become positive. But I was talking about the original function, as in without the modulus function. The turning point for that would be 1 and -4. So the original turning point was somewhere here. When that gets reflected, that will come here. That becomes 1, 4. Okay. Makes sense, right? Yes, that's true. That's true. Please make sure to make some noise about that, A-level students, about paper 3, since Pakistani students might not be supporting you a lot in this because they were not affected. Please make sure that you take this in your own hands now. Make a lot of noise. Make sure that Cambridge accepts this leak, because otherwise they'll just put it under the rug, like they've done to some other papers as well. Okay. Yes, it's not necessary. It's not necessary. I said that before. It's not necessary that you show this, but it's not that difficult to figure that out. So I just calculated that anyway. But the question does not require it. It's not required that you show the coordinates of the turning point. Okay. But since we have the x-intercepts, we know the turning point is exactly in the middle of those x-intercepts. Can we show the dotted part as well? You can show that as long as it's clear to the examiner that you are not considering that as part of the graph. Okay? As long as it's clear to the examiner that you're not considering that as part of the graph, that will be okay. Achha. Now let's look at the next part. Now they're saying the function g is defined by g of x equals this for all real values of x. Find an expression for g inverse of x. How do you find inverse of this function? Let's write that function down. G of x is equal to 4e raised to the power x minus 2 minus 1. That's the function g. Okay. How do you find inverse of this? Apply the standard process. You say let y equals this thing. Let's say y equals g of x. Now the function becomes y equals 4e raised to the power x minus 2 minus 1. Now we need to make x the subject. Now how do we do that? Let's bring 1 to the other side. So it will become 4e raised to the power x minus 2. That equals y plus 1. Divide 4 on the other side. I'll just do that in the same step as well. Divide by 4 on the other side. Now, how do we get rid of this e? X is in the power, right? What we can do is we can take ln on both sides, log base e, right? Take ln on both sides. When we do that, we get ln of e raised to power x minus 2, that equals ln of y plus 1 divided by 4. Now, using the power law, this x minus 2 is going to go down there and become x minus 2 whole multiplied by ln e. That equals ln of y plus 1 divided by 4. And now ln e we know is 1, so just 2 will go to the other side, and the final result that you get is going to be something like this: ln of y plus 1 divided by 4 plus 2, write it in the inverse function form. And the final result therefore is going to be g inverse of x, that is equal to ln of x plus 1 divided by 4 plus 2. That's the inverse function's expression that we were looking for. Okay, that was slightly more work than the 2 marks make it seem to be, but that's how you would do it. Okay, makes sense, right? What can come from permutations and combinations in paper one? In terms of concepts, anything can come. In terms of concepts, anything can come, but they will make the numbers relatively smaller so that it becomes easier for you to calculate them manually. But in terms of concepts, there's nothing that cannot come. Okay? We'll just use smaller numbers. So you won't have big factorials there or big permutations, combinations. You'll have smaller numbers, relatively smaller numbers that you can easily work with. Achha, let's look at the next part now. Question number 3. In this question, time t is in seconds and displacement s is in meters. A particle starts from rest at the origin O. Yeah, so mostly what I've seen until now is that they ask about expansion, but it could be some simple permutation or combination problem as well. With apart from the expansion thing as well, they might ask you a proper question involving some logic as well. However, they will use smaller numbers in that case so that the calculation is not that tedious. Achha. A particle starts from rest. Okay, start from rest at the origin O. It moves in a straight line with constant positive acceleration. It's a velocity time graph. If it starts from rest, that means the graph is supposed to start from origin. At time 0, velocity is supposed to be 0. It moves in a straight line with constant positive acceleration. In a velocity time graph, acceleration is given by the gradient of the graph. Acceleration is given by the gradient of the graph. If acceleration is constant, what that means is that the gradient of the graph is constant. And if the gradient is constant, that means it's going to be a straight line. Okay, when you have constant acceleration, the velocity time graph is going to be a straight line. So this is going to be a straight line. ठीक है. अच्छा. Now, that's one thing that you need to keep in mind now. It is going to be a straight line. They've given us, now we don't know how exactly that line is going to look like for now. It may be like this, it may be like this, right? It could be anything like this. Now, we need to sketch the graph from 0 to 4. So it might look like this or this or this, right? Something like this. What they've given us is at time 4, the displacement is 6. How do you find displacement from a velocity time graph? How do you find displacement from velocity time graph? It's the area under the graph. It's the area under the graph, right? So what we are given is the area under the graph from 0 to 4, that is equal to 6. Achha, now, if you were to draw a straight line, like this, the area under the graph would be a triangle. It's a right angle triangle. What's the area of a triangle? Half into base. Base we know is going to be 4. What about the height? Height is unknown. We can say that is V. That is equal to 6. And that will give us V equal to 6 over 2, which is 3. So that means the graph that we would get from that, that is going to be like this. It's going to go from 0 to 3 on the vertical axis, a straight line like this. That's what the velocity time graph would be in this case. Okay? Will Cambridge take any action or not? It depends on how much noise you make about it. It depends on that. That's what their track record says. If there's a lot of noise, then they accept it. Otherwise, they don't. So make sure that you do that. Post everywhere online as much as possible. Email everyone. Ask your friends to post it online. Ask your friends to email Cambridge and your local institutions, whoever conducts the exams in your country, make sure to do that. Otherwise, they will ignore it. Okay. So please make sure to do that. Chale. Let's look at the next part now. Now they're saying, hence find the acceleration. Now we have the graph now. Acceleration from a velocity time graph is given by the gradient of the graph. We can find the gradient. Let's take this point. One is origin, right? So this point is 4 and 3. So acceleration is just 3 over 4, right? 3 minus 0 over 4 minus 0. What will that become? 3 over 4, or you can say 0.75, and that's the acceleration that we were looking for. Okay, the second part was fairly straightforward. Okay, chale, let's look at the next one. Now they're saying in an arithmetic progression, The common difference is -2. The sum of the first 4 terms is equal to the sum of the first 10 terms. Find the first term. So it's an arithmetic progression, first of all. It's an AP. We have an arithmetic progression, AP. We know that the difference of this arithmetic progression is -2. What we're looking for is the value for A, the first term. Now, what's the information that is given? We are given that the sum of the first 4 terms is equal to the sum of the first 10 terms. S4 is equal to S10. S4 is equal to S10. We just have to input values in the formula. What's the sum formula for an AP? Sn, that is equal to half n into 2 times a plus n minus 1 times the difference. That's the sum formula for an arithmetic progression, right? Input values in that, see what that gives you. Sum of the first 4 terms, that will be 1 over 2 times 4 into 2 times a, we have to find the value for a, plus n minus 1, that means 4 minus 1 times the difference is -2, that equals S10, that means 1 over 2 into 10 into 2 times a plus 10 minus 1 times the difference, which is -2. ठीक है. Sum of the first 4 terms is equal to sum of the first 10 terms. How is that logical? Because some of the terms will be negative, right? So it might be a sequence like this, that it's a decrease since the difference is -2, right? So it might be like this: 6, 4, 2. I'm just giving an example: 6, 4, 2, 0, -2. So let's suppose this sum is 10, right? Then it increases to 12, and then it again becomes 10 if you consider 5 terms. So when some terms are positive, some are negative, at some point you can get the same sum again. Okay, that's what is happening. You can see the difference is also -2, right? Acha. Let's look at the first term. Half into 4, that will be 2. Now this gives us 5. 2 into 2a plus 3 into -2. 3 into -2, that will be -6, right? On the other side, we have 5 into 2a plus 9 into -2, that will be -18. Okay, now let's simplify this. 4a, it's not a good idea to divide by 2 on the other side. It'll introduce fractions, or maybe you can cancel this out actually. But anyway, let's just multiply, avoid fractions. 4a minus 12, that is equal to 10a minus 18 times 5. What is that? That is 90. Now that gives us 6a equal to 90 minus 12, which is 78. What is 78 over 6? 6 times 10. 6 times 10 is 60, times 11, 12, 13 is 78. Okay, so the value for A is going to be 13. That's the first term of the sequence. Okay, that was question number 4. Hopefully they will cancel P3. But for that, they have to first of all accept that it was leaked in the first place. You'll have to make a lot of noise for that. Otherwise, they don't accept. Okay. All right. A curve has this equation. P and Q are the stationary points on the curve. Find dy over dx and the exact length of the line PQ. Okay. So to find the length of the line PQ, we can use the distance formula. But for that, we need the points P and Q. P and Q are the stationary points. How do you find stationary points of any function? How do you find stationary points of any function? You find the derivative, put that equal to 0. Let's do that. Find the derivative, put that equal to 0. Y equals x squared minus 8 divided by 3 minus x. That's the function. How do you differentiate it? It's a quotient, right? We can say this is u, this is v. The quotient rule says vu dash minus uv dash divided by v squared. Right? Input values in that will give you the derivative dy over dx. Now, The denominator is going to be 3 minus x whole squared. In the numerator, we have vu dash, that means 3 minus x as it is, into derivative of x squared minus 8, that is going to be 2x, minus uv dash, that means u as it is, x squared minus 8 as it is, into derivative of 3 minus x, which is negative 1. This is what the derivative turns out to be. Okay. Now put the derivative equal to 0. Put this equal to 0. Because we're looking for stationary points, what are we left with on the right side? 3 minus x into 2x, that becomes 6x minus 2x squared, minus into minus x squared, that becomes plus x squared, and again minus and minus, that becomes plus, and then this minus, that becomes minus again, x squared minus 8. In the denominator, we have 3 minus x whole squared. Now in the next step, we could say it goes to the other side, gets multiplied by 0. The numerator now is a quadratic equation. What I'll do is I'll take the terms to the other side. So this gets eliminated, right? I'll take these terms to the other side as well so that the coefficient of x squared becomes positive. And that gives me x squared minus 6x plus 8 equal to 0. That's a quadratic equation that we're getting from this. Solve this quadratic. Can we factorize this? Yes, it becomes x squared minus 4x minus 2x plus 8 equal to 0. And we get two factors from this. One factor is x minus 4 and the other factor is going to be x minus 2. So x is either equal to 4 or x is equal to 2. These are the x coordinates of the two stationary points. How do you find the corresponding y coordinates? Input them back in the original function. That will give you the corresponding y coordinates. See what that turns out to be. The function that we had, that was, let me just write that on the side, y equals x squared minus 8 divided by 3 minus x. That was the function. Okay, now input values in that, x equal to 4, that will give us y equal to 4 squared minus 8 divided by 3 minus 4. Simplify this, 16 minus 8 is 8, 8 over negative 1, that will be negative 8. Okay, what about the other one? When we put x equal to 2, that gives us 2 squared minus 8 divided by 3 minus 2. In the numerator, we have 4 minus 8, which is negative 4. In the denominator, it's just 1. So the y value turns out to be negative 4. The two stationary points that we're getting, they are 4 negative 8 and 2 negative 4. Okay. We found those two stationary points. Now we don't know which one of them is P, which one of them is Q. It doesn't matter. We just have to find the distance between them, right? So you can call any of them P, any of them Q. Find the distance between them, use the distance formula for that. PQ equals square root of x2 minus x1 whole squared. You can say 2 minus 4 whole squared plus y2 minus y1 whole squared minus 4 plus 8 whole squared. And that will give us square root of 2 squared, which is 4, and 4 squared, which is 16, and that turns out to be square root of 20. And that's our final answer. They asked us for the exact length. They did not ask you to simplify this or something. You can leave it as it is as well, and that will be okay. You can leave it as it is. If you want, you can also simplify this. How do you simplify this? Square root of 20, I could write that as 5 into 4, right? 5 into 2 squared, and then that can be written as 2 under root 5. But both will be acceptable. They did not ask us specifically to give our answer in a simplified third form. So under root 20, that will also be acceptable. Okay, that's our final answer. These were easy 7 marks, nothing complicated there. Okay. Does this always happen with A-level math paper 3? It does not. It's probably the first time that it has happened to paper 3. इस दफ़ा तो बस बहुत ही ज़्यादा extreme cases हो गया ना. पहले तो it was just for paper 1 generally. A-level math paper 1 used to get leaked. The others were generally fine. But इस दफ़ा तो almost everything is getting leaked. Chale, let's look at the next one. Solve this equation. It's a modulus equation. How do we solve this modulus equation? There are two methods of doing this generally. We can use the squaring both sides method or remove the modulus sign, put plus minus in place of that. I prefer the plus minus method. That makes things quicker. So plus minus into 3x minus 3x plus 2, that equals 7. That splits the equation into two parts. 3x plus 2 equals 7. or minus 3x minus 2 equals 7. Now the first equation, what does that give us? X equals 5 over 3. That's one possible solution that we're getting. And the other equation, what does that give us? Minus 9 equals 3x, and the value of x turns out to be negative 3. Now these are two possible answers that we're getting. These are two possible answers that we're getting. Generally, when you get multiple answers, it's always a good idea to check those answers in case of modulus functions, whether they both satisfy or not. In this case, it's not a problem since we have a constant on the other side. Sometimes when they have something like this, maybe 3x plus 2 modulus that is equal to x minus 5, for instance, when you have x on the other side as well, in that case, it's always a good idea to input those values in that equation and see if they actually work or not. Okay. I find this method to be the quickest, plus minus method. That's what I would recommend that you use. Okay. Acha, that was the equation. How do we solve this inequality now? How do we solve this inequality? For any inequality in general, we first of all solve it as an equation. Solve it as an equation first of all. 2x minus 4 modulus, that is equal to x plus 1 modulus. Solve it as an equation to find the critical values. Okay, the points where these two graphs may be intersecting each other. Solve it as an equation first. Now, how do we do that? Remove the modulus sign, put plus minus on any one of the two sides. You can say 2x minus 4, that equals plus minus x plus 1. You can put plus minus on any one of the two sides. Okay, in this case, because even if you put on both sides, you would realize you only end up with two unique cases. Two unique cases. So putting it only on one side is going to be sufficient. When you have modulus on both sides, squaring both sides, that will also work. You can also do that. So it's your choice. You can do whichever of the two methods you prefer. Achha. Now, in this case, we get 2x minus 4 equal to x plus 1. That's one equation that we're getting. And the other equation is 2x minus 4 equals minus x minus 1. The first equation gives us x equals 5. The second equation gives me 3x equals 3. And the value of x turns out to be 1. So the two possible values of x that I'm getting, they are 1 and 5. Now remember, we were solving an inequality. We were not solving an equation. We were not solving an equation. Okay, we were solving this inequality. So what are the solutions of that inequality now? We can do it on a number line. Think of a number line. Mark those 2 points here. One point is 1 and the other point is 5. These 2 points divide your number line into three regions. One is on the left side, one is in the middle, and one is on the right side. You have to check a number in each region and see if that satisfies that inequality or not. When you have modulus on both sides, like in this case, when you have modulus on both sides, we can only get one of two cases. We can only get one of two cases. One possible case is that the middle region is correct and the sides regions are incorrect. That is one possible case that you could get from this. And another possible case is that the middle region is incorrect and the side regions are correct. So basically the same cases that you get for a quadratic inequality as well. So all you have to do is just check the middle region and that will be sufficient. You'll figure out what's the solution going to be. So let me explain what I mean by that. You take one number in the middle region, for example. You can try 2, maybe you can try 3, 4. See if the inequality is satisfied with that. 2 into 2 minus 4, modulus of that is greater than modulus of 2 plus 1. Now, what does that give us? 4 minus 4, that is 0. 0 is greater than 3. Is that correct? No, that's not correct. So that means the middle region is not correct. And if that's the case, the regions on the sides are going to be correct. That is always the case whenever you have modulus on both sides of an inequality. So what's the solution then? It's either this region or this region. Okay, so you get x less than 1 or x greater than 5. This is the final solution that you end up getting from this. Okay. The alternative is using quadratic inequality method. That's perfectly okay as well. When you have modulus on both sides, quadratic inequality method works fine as well. Okay, you can also do that. So if it's the first time we're seeing this, you can just follow whatever method you're more comfortable with. Yes, exactly. This is the modulus topic that we do in A-level maths paper 3 as well. So it's pretty similar to that, yes. ठीक है, चले. Let's look at the next one now. So now we've got two variables, x and y. They're related by this equation. We need to use calculus, that means differentiation or integration, to find the approximate change in y when x increases from 4 to 4 plus h, where h is small. So now we've got approximate change. How do we do such problems involving approximate change? First of all, find the derivative of this function, and then we'll see. Find the derivative of that function, write it in the proper form. In the power form, 3 under root x, we can write that as 3x raised to the power 1 over 2. And then 1 over under root x, we can write that as x power negative 1 over 2. Write the function in the power form like this, first of all. Find the derivative of this. What's the derivative going to be? dy over dx, that is equal to 3 as it is, multiplied by the power, subtract 1 from the power, and then multiply by the power again, which is negative 1 over 2, subtract 1 from the power. Achha, now that's the derivative. We want to find the value of this derivative at x equal to 4 first of all. Find the value of the derivative when x is equal to 4. And then we'll talk about approximate change after that. Let's find the gradient of the curve at this point. What's the gradient of the curve at this point? Put x equal to 4 in this and simplify this. Now calculator is not allowed, so you'll have to do the simplification yourself. Let's see how we can do that. We have 3 over 2 outside this number, and then x power negative 1 over 2. I could write that as 1 over 4, or let me actually show one more step so it doesn't confuse anyone. Let me just input it as it is first. 4 raised to power negative 1 over 2, and then we have minus 1 over 2 into 4 raised to power negative 3 over 2. So how do we evaluate this now? I could first of all make the power positive. That will simplify things a little. So let's take 4 to the denominator. So we have 4 raised to power 1 over 2, and then minus 1 over 2 into 4 raised to power 3 over 2 in the denominator as well. How do we simplify this now? 4 raised to power 1 over 2, square root of 4 is 2. So that becomes 3 over 2 times 2 minus 1 over 2. What about this? 4 raised to power 3 over 2. We can think of it like this. 4 raised to power 1 over 2, whole power 3. What will that give us? 2 raised to power 3, which is just 8. So in the denominator, we've got 8. Now you can skip maybe 1 or 2 steps here and that will still be okay. But just make sure that you're not making any careless mistakes when you skip steps like that. Achha, let's simplify this. 3 over 4 minus 1 over 16. That's what I'm getting. Let's take LCM of this. We can make this number 16 by multiplying by 4 in the numerator and the denominator, and that gives me 12 minus 1 in the numerator, so 11 over 16. This is the value of dy over dx that we're getting. This is the value of dy over dx that we're getting. Okay. Now, once we've got the derivative, how do you find this approximate? Just give me a minute, I'll answer your question. Let me just complete this. Find the approximate change in y. Approximate change in y when x increases from 4 to 4 plus h. Now, what's the change in x in this case? Delta x. What's the change in x? 4 to 4 plus h. The change is h, right? You can do the subtraction 4 plus h minus 4. That gives you h. So the change in x is h. Now, we know that small change in y over the small change in x, that is the same as dy by dx. It's approximately the same, not exactly. It's almost the same as the dy over dx value at that particular point. Now we know the change in x at this point. That is h. So we could say change in y divided by h, that is approximately equal to 11 over 16. And therefore, the change in y that they were asking about, that is going to be 11 over 16 times h. Now, this is just for your understanding. You could write this directly in one single step. You could write this directly in one single step, and that's okay. ठीक है. And that will be the final answer. All right. Wait for their update. Wait for their update. That is going to come on 22nd. I think they also said that they might give an update today. I'm not sure. They might actually give an update today as well, but there is a confirmed update coming on 22nd. Wait for that because they might give an option of withdrawing from the exam after you've actually taken the exam as well. That might be a possibility because in the previous years they've been doing this. Although that wasn't the case of expected grades, but they might give that option that even if you sit for that reset, uh, you have an option of withdrawing. But in any case, delay it as much as possible. So maybe spend the next 10-15 days in preparing for it as much as possible. Since you've already prepared for all the papers, I think it's a good idea to get done with it right now. If you're well prepared, there's no point of delaying it to October, November. Most likely they will be doing retakes of these papers. If you're well prepared, just keep doing some revision and then closer to the exams you can make more effort and give those exams again. That should be fine. Have they sent a message? I actually have been out of touch. Okay, so they have sent something. They have sent something. I've not read that yet. Let me see. All candidates in Pakistan must sit the new replacement paper on 9th June. If you don't want to, that's for just for paper one. For A-level students, 13-month carry forward rule has been extended if you withdraw and re-enter in November 26. November 26, entry fee will be the same as June. You cannot withdraw only one component. You have to withdraw the entire syllabus. Okay, so you have time, right? You can withdraw with full refund until 17th June. So don't decide something in a hurry right now. Do not decide something in a hurry. There's time, right? Think about it, take your time. I would say if you're well prepared, get done with it, right? Otherwise, it'll be a lot of hassle doing everything all over again for November. You'll start forgetting stuff and it'll require a lot more effort again. It'll be easier to get done with the exams in June uh, in this same session. It's not very clear if you can give the retake and still opt for withdrawal. It's not very clear. So maybe they will make it clear later, but still there's a lot of time yet left. Wait for the next update. Wait for the next update. In the meantime, keep revising. But you do have that refund option in any case. They've offered a full refund until 17th June if you apply until 17th June. ठीक है चले. All right, let's move on to the next question. Question number 8. Let's try this now. A curve has this equation. Y equals x e raised to power x e raised to power 2x plus 1. We need to find dy over dx. Find dy over dx. Now it's a product. It's a product. Two things are multiplying. We can say this is u, this is v. What does the product rule say? The derivative is going to be uv dash plus vu dash. Let's find the derivative dy over dx. dy over dx. How do you do that? U as it is. That means x as it is into derivative of this. Derivative of e power 2x plus 1, that is going to remain e power 2x plus 1. You just have to multiply by the derivative of 2x plus 1 as well, which is 2 plus vu dash e raised to power 2x plus 1 as it is into derivative of x, which is just 1. That's dy over dx. You can simplify this a little. 2x e raised to power 2x plus 1 plus e raised to power 2x plus 1. And that's your final answer. That's the first part that you had to do in the first part. ठीक है. Achha. Let's look at the next one now. Now they're saying the line L is the tangent to the curve at the point where x is equal to 1 over 2. Find the exact coordinates of the 2 points where the line L meets the axes, meets the x and y axes, right? Now, how do you find x and y intercepts of a line? You need the equation of the line. Once you've got the equation of the line, you can find the intercept for that, right? By putting x equal to 0, y equal to 0. So we first have to figure out the equation of the line. Now, what do you need for equation of a straight line? You need two things. You need a point on the line and you need the gradient of the line. What point are they talking about? When x is equal to 1 over 2. That's the point that they're talking about. The function is y equals x e raised to power 2x plus 1 and the derivative dy over dx, that is equal to 2x e raised to power 2x plus 1 plus e raised to power 2x plus 1. Okay, just give me a second. Just give me a second. Okay. Achha. Uh, we want to find the equation of the line, right? Equation of the tangent. Now, x equals 1 over 2. What we can do is we can input x equal to 1 over 2 in this original curve. That will give us the point that we need. The point that we need. Let's input this here. Y equals 1 over 2 into e raised to power 2 into 1 over 2 plus 1. Simplify this and that gives you 1 over 2 into e raised to power 1 plus 1, which is 2. 1 over 2 e squared. This is what the function turns out to be. Okay. This what the y value turns out to be. So you have a point now where x is 1 over 2 and y is 1 over 2 e squared. They want an exact answer, right? Now find the gradient of the line at that particular point. What's the gradient of the line going to be? You put x equal to 1 over 2. You put x equal to 1 over 2 in the derivative as well and see what that gives you. Now, what does the derivative turn out to be? Dy over dx, that is equal to 2 into 1 over 2 into e raised to power 2 into 1 over 2 plus 1 plus e raised to power 2 into 1 over 2 plus 1. ठीक है. Let me just check it again. 2 into 1 over 2 e raised to power 2 into 1 over 2 plus 1. Yeah, that looks okay. Let's simplify this. E raised to power 2, that's what we're getting from this. This and this, they get cancelled. This also gets cancelled. And from the other one, we have e squared as well. And that gives us that the derivative, the gradient is 2e squared. That's the gradient of the curve at that point. If that's the gradient of the curve at that point, what about the gradient of the tangent? What about the gradient of the tangent? It will be the same as the gradient of the curve. If it comes in paper 2, you should still avoid using decimals. You should still avoid using decimals. In equations, you avoid using decimals as much as possible. So even if they did not specify anything, it's a good idea to keep it in terms of e. Okay, when you write any equation, avoid decimals as much as possible. Use exact values. Okay, now we have a point and we have the gradient. We can write down the equation of the line y minus y1. That means y minus 1 over 2e squared equals m, which is 2e squared into x minus x1. That will be x minus 1 over 2. That's the equation of the tangent that we were looking for. Okay. Achha, now there's no need to simplify this. There's no need to simplify this. Yeah, in this case, the question says exact form, but there was a question there that in paper 2, if it comes and they do not mention that they want exact answer, in that case as well, as much as possible, we prefer using exact answer, exact form. Okay, sometimes it will not be possible and you have to convert it to decimals, but as much as possible, you prefer keeping it in exact form. Achha, we've got the equation of the tangent. Now, there's no need to convert it to another form. Just find the intercepts directly now. Just find the intercepts directly. X-intercept and y-intercept. How do you find them? Put x equal to 0 for the y-intercept and put y equal to 0 for the x-intercept. Just put them directly here in this form. If I put x equal to 0, what does that give me? I get y minus half e squared, that is equal to 2e squared into 0 minus 1 over 2. Simplify this. 2e squared into minus 1 over 2. 2 and 2 will get cancelled and we would be left with minus e squared. This goes to the other side and we have plus half e squared and that will become minus 1 plus 1 over 2. That's minus 1 over 2, right? So this will be minus 1 over 2 e squared. You can take LCM and then simplify. This is what you would end up getting. So one point that you're looking for is 0 negative 1 over 2 e squared. This is one point that we're looking for. Okay, that's one answer. What about the other one? If you put y equal to 0, that gives us 0 minus 1 over 2 e squared, that is equal to 2e squared into x minus 1 over 2. What do we do now? Let's divide this on the other side. Divide by 2 on 2e squared on the other side. E squared and e squared will get cancelled and we would be left with minus 1 over 4, right? Let me just show that step here as well. So we have minus 1 over 2 e squared. Let's bring that 2e squared from the other side to this side. What are we left with there? X minus 1 over 2. Now e squared and e squared get cancelled. We can bring 1 over 2 here as well. So it becomes minus 1 over 4 plus 1 over 2. It's a good idea to write the other way around. That will make it easier for you to calculate it in your head. 1 over 2 minus 1 over 4. Okay, now what's that? That will become 1 over 4, right? 2 over 4 minus 1 over 4, that's 1 over 4. So the second point that we were looking for, that is 1 over 4 and 0. This is the x-intercept of the graph. That's what they wanted us to figure out. X-intercept and y-intercept. That was quite some working for 5 marks. That's our final answer. Is that okay? Any issues with this? Achha, by the way, tomorrow I plan to do difficult questions from 3 papers. I think not 2, 3 papers. So what I am thinking of is that we do difficult questions from November 25 papers, the ones that we are left with, variant 1 and variant 3, and the March 25 paper. So we do difficult questions from these 3 papers tomorrow, and then difficult questions from all the 3 June components on Sunday, inshallah. Okay, that's what I'm thinking of. I'll post polls in the WhatsApp group to decide which questions you would want me to do. You will decide which questions are difficult from those papers, and we'll just focus on those questions tomorrow and on Sunday, inshallah. Okay, acha, let's look at the next one now. Now they're saying use your answer to part A to find this integral. Integration of x e raised to power 2x plus 1 with respect to x. Now, how do we do that? How do we do this integration? It's a product, right? X e raised to power 2x plus 1. For differentiation, we have a product rule of differentiation. For integration, you do not have the product rule of integration in your syllabus. So how do you do that? That's the reason they have asked you to use the first part. Now, how is the first part relevant? Let's understand what we've done the first part. What we have done is we have differentiated this function and that gave us this thing. Okay, all right. Let me just write that down here. So in the first part, what we did was we said the derivative with respect to x, derivative with respect to x of x e raised to power 2x plus 1. Derivative of x e raised to power 2x plus 1. Yeah, that's what we found in the first part. And we said that is equivalent to 2x e raised to power 2x plus 1 plus e raised to power 2x plus 1. This is what we figured out in the first part. Okay, this was the result from the first part. Now, how do we use that to find this integral? How can we use that to find this integral? Now, you see, the integration that we're looking for is of this thing, x e raised to power 2x plus 1. Now, that's appearing here, and it's also appearing here. What we can do is, we can say it's an equation. Let's apply integration on both sides. Integrate both sides with respect to x. Integrate both sides with respect to x, integrate this with respect to x, integrate this with respect to x, integrate this with respect to x. The whole equation you integrate with respect to x. Okay? Achha, now what happens on the left side? Integration and differentiation, they are reverse of each other, they are opposite of each other, so they get eliminated, right? And on the left side, we're just left with x e raised to power 2x plus 1. Right? Integration and differentiation, they are opposite of each other, right? So they get cancelled, kind of. Okay, what about the left? What about the right side now? On the right side, we have 2x e raised to power 2x plus 1 integration of this. Now, it's a product. We don't know how to evaluate the integral of this product. Let's leave it as it is. What about this? Integration of e raised to power 2x plus 1. This is something that we know how to do. E raised to power some linear expression. How do we integrate that? We say it remains e raised to power 2x plus 1. And we divide by the derivative of 2x plus 1, which is 2. So now you see, we have one term that still has integral sign on it, and it's very similar to what we want to evaluate at the end. It's very similar to that. Let's make this thing the subject. Let's make this the subject. So what I'll do is I'll just keep it on the right side and take the rest of the terms to the left. So I have 2x. Now, what they want is x e power 2x plus 1. I also have 2 here. So I can write 2 outside the integral. It's a constant that's multiplying. We can write it inside or outside, it doesn't matter. So x e raised to power 2x plus 1 with respect to x. Take everything else to the left side. That becomes x e raised to power 2x plus 1 minus e raised to power 2x plus 1 divided by 2. All you have to do now is divide this 2 on the other side. Divide this 2 on the other side. See what that gives you. Integration of x e raised to power 2x plus 1 with respect to x. That's this thing. If you divide 2 on the other side, that will give you 1 over 2 x e raised to power 2x plus 1 minus e raised to power 2x plus 1 divided by 2 into 2. That will be 4. That's our final integration. Whenever we integrate without limits, we also have a plus c. So we will write a plus c at the end in our final result as well. And that's the integration that we were looking for. That was a bit complicated, actually. You will learn in A levels, this is actually how we derive a product rule for integration as well. We call that integration by parts. You will study this in A-level maths paper 3 later on. It's called integration by parts. It's the product rule of integration. It's derived from the product rule of differentiation. So we have kind of done that derivation here. We derived from this product rule, that product rule for integration. And that's how you would approach this. Any questions in this? This was, I think, a bit tricky. Let me know if there's any problem. Take it. Okay. Let's look at the next one. Question number 9. Question number 9. In this question, time is in seconds. Okay, that's a long statement. Let's slow it down a little. Make sure that we're not making any careless mistakes. So we are given time, that is in seconds. Okay. Distance is in meters at time 0. At time 0, particle A starts at the origin. So it's starting from the origin. So its displacement at time 0 is 0. It moves with velocity to 1. It moves with this velocity to 1. Yes, you just integrate both sides of the derivative. So what they made you find in the first part, this derivative, all you have to do is just integrate both sides with respect to x. So this derivative is going to get cancelled, and you'll just make that thing the subject that you want at the end then, and you'll get the result. Okay, so once you have done a couple of questions like this, it's kind of repetitive after that. ठीक है. अच्छा. We have this particle A that starts at the origin and moves with velocity to 1. At the same time, particle B starts from the point with position vector -3, 4 and moves with velocity 4, -2. Okay, so it's starting from this point. It's starting from this point. That's the starting point. So we could say the position vector of B, what would that be? Its initial point is 2, 1, right? I'm sorry, that's -3 and 4. That's the initial point. It moves with this velocity. So every second, what happens now is it moves 4 units to the right, 2 units down. So we add 4 and -2 to this, multiplied by time. So if time is 1, it moves 4 units to the right, 2 units down. If time is 2, it moves 8 units right, 4 down, and so on. That's what the position vector of B turns out to be in this case. ठीक है. That's what the position vector turns out to be. Now they're saying, determine whether or not the particles collide. Now, how do we determine something like this? How do we determine if there's a collision between two particles when you have their displacement vectors like this? If there's a collision, the position vectors of both the particles will be the same at that particular point. Okay, so if there's a collision, at that point of collision, the position vectors of both the points will be the same. They will be equal to each other. So what we do is we put the position vectors of both of them equal to each other. What's the position vector of the first particle? It was starting from origin, so the position vector would just be the velocity vector multiplied by time, right? You can say 0, 0 plus 2, 1t, right? Or just 2, 1t directly. That must equal -3, 4. I'll just simplify this. -3 plus 4t and 4 minus 2t. We should get some solution of this equation. We should get some solution of this equation if they do indeed collide. Okay, I'll just do it in 2 steps. -3, 4 plus 4 minus 2t. This is what we have, right? Let's simplify both sides. On the left side, we get 2t and t. On the right side, we get -3 plus 4t and 4 minus 2t. Okay. Now, we're getting two equations from this. This is one equation from the x components and another equation from the y components. Solve those two equations, see what we get from that. The first equation, 2t equals -3 plus 4t. Now, that is going to give us 2t equal to 3. The value of t turns out to be 3 over 2, which is 1.5. The second equation, that is t equal to 4 minus 2t. 3t equals 4. T equals 4 over 3. The other one was 3 over 2, right? They're not equal. They're not equal. What that means is there is no time instant. There is no time instant at which the two particles have the same coordinates. So they never meet each other. If the values of t from both of them were the same, we would say there is a collision. In this case, the value of t is different for both of them, so there is no collision in this case. Okay, so we can write down a conclusion here. We have to determine whether the particles collide or not, right? So we have to write down a conclusion at the end as well. We can say they are different. There are different values of t from both of those equations. That means A and B, they do not collide. There is no collision. There's no collision. Okay. That's the final result that we get. Okay. Chale, let's move on. So now they're saying the point Q has position vector this. Point R has position vector this. Point S has position vector this, where A and B are integers. Okay. It's given that S lies on the straight line QR. Find the possible values of A and B. Okay, so we're given the magnitude of the RS vector. Let's start from that. That's the simpler piece of information. First up, let's do that. Let's use that first of all. RS vector. Let's find that vector first of all. What is RS vector going to be? Position vector of the second point, that is OS, minus the position vector of the first point, that's OR. What is OS? OS is AI plus BJ, subtract from that OR, which is minus I plus 4J. Now, what do we get from that? The I component, let's show one more step. AI plus I plus BJ minus 4J. Now the I component is A plus 1 and the J component, that is B minus 4. Right? That's what we're getting. That's the vector RS. Now they are saying the magnitude of this vector, that is equal to square root of 5. Apply the magnitude formula, square root of x squared plus y squared, right? So that means A plus 1 whole squared plus B minus 4 whole squared, that must equal square root of 5. Take square on both sides. Take square on both sides. And that gives you a plus 1 whole squared, a plus 1 whole squared plus b minus 4 whole squared equals 5. Okay. Now this is one equation that we're getting. We have two unknowns. We cannot really find the values of a and b from this. We need one other equation as well. Now where do we get another equation from? Where do we get another equation from? S lies on the straight line QR. What does that mean? If S lies on the straight line QR, let's just try to visualize this. Now, it's not very accurate. I'm just drawing a random. I'm drawing a random line. Let's suppose for a random line, R was here maybe, and okay, let's make it slightly more precise maybe. For R and S at least. So if R is here, J would be. If R is here, Q would be maybe here. Yeah. Okay. So we have these 2 points, R and Q. Now they're saying S lies on the line QR. So S is somewhere on this line. We don't know where exactly. Let's say this is here. Now what does that mean? These 3 points are collinear. They're collinear. They lie on the same line. They lie on the same line. If they lie on the same line, what does that mean? The gradient of any combination of vectors made from these points, RS, SQ, RQ, they are all going to be the same. Okay. So what you do is You find the gradients of any two of those lines, any two of those vectors, and equate them. Or you could also use that parallel vectors method. You find the ratios of corresponding components and equate those. It'll also work like that, right? Now, one vector we've already figured out. Rita, I'll answer your question in a moment. RS vector we already figured out. Now, what about another vector? Let's find another vector. I'll use the one that we know both points for, Q and R. Let's take that as another vector. Let's find QR vector and see what that turns out to be. That will be OR minus OQ, right? OR is minus I plus 4j. Subtract from this 3I plus 2j. Now, what does that simplify to? Minus I minus 3I, that is minus 4I. 4j minus 2j, that will be plus 2j. That is the vector QR. Now, since they are collinear, they lie on the same line, the directions have to be the same for both of them. This vector and this vector, they are supposed to have the same direction. They are supposed to have the same gradients. So we can make an equation from this. We could say gradient of the first vector, that will be b minus 4 divided by a plus 1, the y component divided by the x component, right? Change in y over change in x, that's what it is. That equals 2 over negative 4. That's another equation that we're getting. Let's simplify this. 2 over minus 4, that becomes 1 over negative 2, right? Negative 1 over 2. Let's cross multiply. If I multiply minus 1 there, what does that give me? Minus 2 there, sorry. That will become minus 2b plus 8. On the other side, I have just 1. So 1 into a plus 1, that will be a plus 1. That's another equation that we're getting now. That is a plus 2b equal to 7. You've got these two simultaneous equations, solve them, and that will give you the values of a and b. ठीक है. If you're from India, you sure have a lot of students taking this particular exam there, right? Make sure to make a lot of noise about it. Post everywhere on social media, email British Council in your country. Unless you make a lot of noise, they're not going to accept it. They're not going to accept it. Okay, so make sure to make a lot of noise. A-level Maths B3 students outside Pakistan, it's important that you speak up everywhere. Otherwise, they will ignore it like they ignored business paper, accounting paper, IGCSE math. Don't let that happen. Ask everyone around you to email British Council if that's what conducts the exams in your country. Okay, how do we solve this now? Is there another way to do this? Uh, Not really. The only other possibility would be that you use the idea that that parallel vectors have the same ratios of corresponding components. That will be the same amount of working. This you still have to do. This you have to do as well. So there's nothing more efficient that you can do here. Now let's solve these simultaneous equations. From the second equation, I could say let's make A the subject, and that will give me 7 minus 2b. Input that in the first equation. Achha. Now, what does that give me? A equals 7 minus 2b. So that will be 7. So this equation had squares on both A and B. So it will not be a good idea. It will not be a good idea to make A or B the subject from here. That will make you work with square roots eventually. You don't want to do that. So let's just make A the subject from the linear equation, put that here. What do we get? 7 minus 2b plus 1 whole squared plus b minus 4 whole squared equals 5. Actually, there's azan going on here. I'll just do this working silently for the next minute and then we resume after that, okay? Okay, so what I've done is I made A the subject from the second equation. I put that in the first equation, and that gave me this. This is A minus B whole squared identity. This is also A minus B whole squared identity. Just expand it using that. Simplify everything, you get a quadratic equation from that. Okay, now these are big numbers. You are not allowed to use a calculator. So I simplified them first. All of them were multiples of 5. So I divided the whole equation by 5. And that gave me this thing. Then we factorized, found the two values of B, 5 and 3. Put them in the other equation now. That will give you the corresponding values for A. So A equals 7 minus 2 into 5. And that turns out to be minus 3. And from the other case, we get A equal to 7 minus 2 into 3, which turns out to be 1. So the values that we're getting are A equals negative 3 with B equal to 5. This is one set of values, and the other set of values is A equals 1 and B equals 3. And that's what we were looking for. That is our final answer. ठीक है, makes sense to everyone? Any issues with this? Any problems? Anyone? ठीक है. Okay, let's look at the next one now. Question number 10. Okay, that's a 6 mark log question. Another 4 marks. That's a lot of marks and logs in this paper. Chale, let's do this now. Log of x squared with base 5 minus log of x with base 5 minus 3 log of 5 with base x, that equals to, we need to find the value of x from this. Abdullah, I'm not sure what you mean by that. Can 8s s what? Okay, acha. How do we solve this equation now? How do we solve this equation? We've got base 5 here. This is base 5. This is base x. Can we make this base 5 as well using change of base law? Let's start with that. We can say log of x squared base 5 minus log of x base 5 minus 3 as it is. If I want to switch these numbers, 5 here and x there, I can write this as 1 over log of x with base 5. Right? On the other side, I've got 2 as it is. Yeah, this is what we're getting from this now. Now the bases of all the logs are the same. Bases are all the same now. Now we need to simplify this a little. How do we do that? Now, before we multiply there, it's going to make things complicated, right? Because it'll be square of logs, too much complication there. What I'll do before multiplication is I can simplify this log, these two logs, because what we have is two log terms are being subtracted. Two log terms are being subtracted. We can use the division law on this, and write it as log of x squared over x, base 5. Okay, simplify this first a little. Minus 3 over log of x base 5, that equals 2. And now x squared and x, they get cancelled, and we are left with log of x base 5, and that's pretty useful now because we have exactly the same term in the denominator here as well, and now it becomes straightforward. Multiply this with the whole equation. So I'll just multiply the whole equation by this thing so that we get rid of the denominator, or you can take LCM here and then multiply on the other side. You can do all of that in one single step, multiply by the LCM. Just multiply the whole equation by this, and that will give you log of x base 5 whole squared minus 3, that equals 2 log of x base 5. And now you can solve this equation. How do we solve this equation now? It's a quadratic equation. It's a quadratic equation in log x base 5. We can use a substitution. Substitution will make it slightly easier to work with, right? Let's do a substitution because this thing and this thing, they're exactly the same. So substitution is going to help here. Let's say some other letter, maybe u, that equals log of x base 5. Now this becomes u squared equal to, no, u squared minus 3 equals 2u. That's a quadratic equation. Solve it as a quadratic. Now u squared minus 2u minus 3 equal to 0. Can we factorize this? U squared minus 3u plus u minus 3 equal to 0. We get two factors from this, u minus 3 and u plus 1. So that means u is either equal to 3 or u is equal to negative 1. Now put that substitution back. Log of x base 5, that is equal to 3, or log of x base 5, that is equal to negative 1. Now, how do we convert this log form to index form? This number 5 is going to go to the other side, become the base of this number 3 in power form. And that gives us x equals 5 raised to power 3 and x equals 125. This is one possible value of x that we're getting. From the other one, take 5 to the other side in this case as well. And that will give you x equals 5 raised to power negative 1, which is the same thing as x equals 1 over 5 or 0.2. And that's your other possible answer. You're getting multiple answers. Whenever you have multiple answers, it's always a good idea to go back to the question statement and see if multiple answers are possible. So given this, they wanted us to find the value for x. Okay, now, are both of them going to be possible? Do any of them cause any problems in this log? There is no problem there. In this log as well, there is no problem. Nothing becomes negative, and the base here is also positive. So yeah, we don't have any problems. So these are the final answer that we get. Okay. Any issues with this? Makes sense? Now you can verify this on your calculator as well if you want. Let me just do it. So I could just put that whole equation on the calculator like this, right? Log of, no, in fact, I'm sorry. What am I doing? Calculator is not allowed, right? You would just think of what would happen if you were to input this here, just to do a quick check. Calculator is not allowed. So log of 125 squared. 125 is 5 raised to power 3, right? So it will become log of 5 cube, basically, right? 5 cube whole squared, base 5. Okay, minus log of 125 base 5 minus 3 log of 5 base 125, that equals 2. Now you can, try to do this calculation, at least just check one of them, and that will confirm the other answer is also correct because they're both coming together, right? From that same working. So in this case, this first one, this is going to give me 6, right? Because log of 5 raised to power 6 base 5, that will be 6. What about the second one? This is log of 5 raised to power 3 base 5. That will be negative 3, and we have negative 3 outside. What about this? I could say 125. What power of 125 is going to give us 5? We could write it as 125 raised to power 1 over 3, right? And that will give us 6 minus 3 into 1 over 3, and that indeed simplifies to 2, and that's what we've got on the right side as well, that is 2. Okay, if you understand that, that is how you could verify this quickly as well, right? If you have time, of course. If you have time at the end of the paper, you could do this verification. And if one is correct, the other is coming from the same calculation, you can be pretty sure that that is also going to be correct as long as you are not getting something negative inside the log function or the base. We're not getting that, so both answers are possible. Okay, that's question number 10 part A. Let's look at the next one now. Let's look at the next one. Question number 10, part B. It says solve this equation. Solve this equation 2 into 10, 2 into 8 raised to power 2x plus 1 minus 3 into 2 raised to power 3x plus 4 minus 64. Acha, what do we do in problems like these? When we have plus minus between terms like this, we have x in the power, right? There's x in the power. So to bring x down, we need to take log on both sides at some point. But the problem is, if we take log any base, first of all, on the right side, we've got 0, but we could try to do something about that by taking 64 to the other side. The problem is this minus sign. When you have minus or plus inside the log function, there's no way to simplify that. You cannot simplify that anymore. So problems like these, we have to solve using some kind of substitution. Now think about what numbers is x coming in the power of? X is coming in the power of 8 and x is coming in the power of 2. So you have to make it the same number in the base somehow. This is 8, this is 2. It's easy to make them the same number, right? 8 can be written as 2 cube. So I could write this as 2 into 2 cube. 8 could be written as 2 cube. 2 cube raised to power 2x plus 1 minus 3 into 2 raised to power 3x plus 4 minus 64 equal to 0. Okay. Now the idea is we want to isolate 2 raised to power x from this. We want to isolate 2 power x from this. We can do a substitution on that then. Okay. How do we isolate 2 raised to power x? First of all, let's simplify this a little. 2 raised to power 3 into 2x plus 1. I could say this is 6x plus 3. 3 into 2 into 3x plus 4 minus 64 equal to 0. Now, the powers are getting added. We could write it as 2 raised to power 6x into 2 raised to power 3. Similarly, here as well, I could write this as 2 raised to power 3x into 2 raised to power 4, right? Using indices rules. If bases are the same, powers get added. We're just doing the opposite of that. So basically, I'm using this rule. A raised to power m into a raised to power n. That gives us a raised to power m plus n. We're using this rule in the reverse direction. Now, how do we isolate 2 power x? How do we isolate 2 power x? 2 into 2 cube, we could simplify that and that becomes 16, right? This 2 raised to power 6x, I could write as 2 raised to power x whole raised to power 6. I could write 6 outside the bracket like this. And then minus 3 into 2 raised to power 4. 2 raised to power 4 is 16. 16 times 3, that is 48. 16, 32, 48. So it becomes 48 multiplied by 2 raised to power 3x. I could write this as 2 raised to power x whole raised to power 3. And then outside we've got minus 64 equal to 0 as it is. And now you see what we have done is we have isolated this 2 power x. This is where we can use a substitution now. We can substitute this with another letter, maybe u or some other letter, doesn't matter. I could say let u equals 2 raised to power x, for instance, and that gives me 16 u raised to power 6 minus 48 u raised to power 3 minus 64 equal to 0. We could simplify this equation a little because these are all multiples of 16. So 16 divided by 16 is 1, u raised to power 6, and this will become minus 3u cube minus 4 equal to 0. How do we solve this equation now? Power 6 equation. It's a disguised quadratic. It's a hidden quadratic equation. So we could again use a substitution. You can do it without substitution as well. If you are comfortable doing it that way, that will work fine. Or you can do another substitution. That's also okay. I could say, for instance, let some other letter now. So let's say, I don't know, y. Y is not used in the equation, right? It's not. Let y equals u cube. Substitute the smaller power with another letter. Okay. So now you've got y squared minus 3u minus 4 equal to 0. And that becomes, can we factorize this? Yes, it becomes minus 4u plus u minus 4 equal to 0. We get two factors from this, y minus 4. Okay, I'm mixing up y and u here. This was supposed to be y. 4y plus y, we get y minus 4 and y plus 1. So the value of y turns out to be either 4 or turns out to be negative 1. Now put this substitution back first of all. In place of y, you put u cube. So you get u cube equal to 4 or u cube equal to negative 1. Okay, now what we were looking for was the values of x. Okay, let's take cube root on both sides. U is equal to 4 raised to power 1 over 3. And here u is equal to negative 1. Cube root of negative 1 is just negative 1. Now put that initial substitution back and we get 2 raised to power x equal to 4 raised to power 1 over 3. On the other side, we have 2 raised to power x equal to negative 1. Now, a positive number raised to power anything can never be negative. So this is not possible. This will not give us any result, right? This is not possible. If you were to try taking log, for instance, think of it that way. If you take log on both sides, log of the right side is not possible. So that is going to be undefined. So this is not possible. What about the left side? I could write this as 2 power x equal to 4 can be written as 2 squared and then power 1 over 3. Therefore, 2 raised to power x equals 2 raised to power 2 over 3. Bases are the same, so the powers must be the same as well. The value of x turns out to be 2 over 3, and that is our final result. That is what we were looking for. The value of x turns out to be 2 over 3. ठीक है. Any issues with this, anyone? Can we solve it using exponential law? How exactly? How would you solve it using exponential law? Yeah, we'll have a break now. We'll have a break now because we still have two questions left and it's going to take time. It's going to be late for Maghrib otherwise. Let's have a break now. Let's have a break now for around 10 minutes, inshallah. And then we resume. We resume around 7:25. Okay, chale. Let me write that down here. This is the next question that we're doing after this. So in Lahore, it's Maghrib time. So we are going to have a break until 7:25 p.m. Okay, chale. We'll be back. Okay, everyone, chale. Let's resume. Question number 11. Let's do this now. It says a curve has this equation y equals minus x squared plus 3x minus 2a squared. That's a quadratic equation. Where a is a positive constant, the area of the region enclosed by the curve and the x-axis is 9 over 16. Find the value of a. Now it's a quadratic function. It's a quadratic function. The coefficient of x squared is negative, right? So it's going to be an n-shaped curve, right? Inverted U, a sad face, that many of you call this. So it's going to be something like this. What we are supposed to do is we have to do something with the area between the curve and the x-axis. That's this area. Now, how do you find area between a graph and x-axis? You use integration for that. But for that integration, you need limits. You need limit for that integration. Do we have limits given here? No. So first of all, what we need to do is we need to find the limits. These are the limits. How do you find them? These are the points where the graph cuts the x-axis, the x-intercepts of the graph. How do you find x-intercepts for any function? You put y equal to 0. So we start with that. We start by finding the x-intercepts of this function. Minus x squared plus 3ax minus 2a squared equal to 0. Let's try and solve this quadratic. I'll make the coefficient of x squared positive by taking everything to the other side. That will simplify things a little. X squared minus 3ax plus 2a squared equal to 0. ठीक है. अच्छा. Now, if you find factorizing this expression difficult, you can also use quadratic formula, simplify that. You'll have to do it manually, but that will work. If you get stuck here because of the a and you can't figure out how to factorize, put values in the quadratic formula, simplify, and you'll get the possible values of x from that. But if you want to factorize, just think of the numbers. Think of negative 3 here, think of 2 here. So multiplication should give you 2 and then addition should give you negative 3. What you can do is you can use minus 2 and minus 1 and you can break it like this. You can say x squared minus 2 minus 1 and then plus 2a squared. Now multiplication needs to give you a squared. So there will be ax with this term and ax with this term. So what we are doing is we are breaking that term, the middle term, into two parts. This part and this part, right? Minus 2ax and minus ax. One, we can just ignore that as well. So minus 2ax into minus ax. If you find this confusing, the alternative is input values in the quadratic formula and that will work. Let's take x common. That leaves us with x minus 2a. Take minus a common from this. That leaves us with x minus 2a here as well. Now that gives us two factors. One factor is x minus a and the other factor is x minus 2a. So x is either equal to a or x is equal to 2a. So the limits that we have got, they are going to be a and 2a. These are the limits of this integration. Now we know the area between the graph and the x-axis, that is 9 over 16. This area is 9 over 16. So when we do integration now, we can put that area equal to 9 over 16. Let's do integration. Integration of that function minus x squared plus 3ax minus 2a squared. Use the original function. Do not use this. This is after we multiplied that by negative because that was an equation. We can't do that with this function. We have to use the original function with the coefficient of x squared being negative 1. We have to integrate this with limits from a to 2a. And they are telling us that the result from this integration has to be 9 over 16. So put this equal to 9 over 16. Solve this equation and that will give you the value for a. Let's do that. Let's do the integration. Integration of minus x squared minus x cubed divided by 3. Integration of 3ax, 3a remains as it is, add 1 to the power, divide by the new power. And then minus 2a squared, and that's a constant, right? Integration of a constant is just that we multiply that with the variable which is x in this case. Now on the other side, we have 9 over 16 limits are from a to 2a. Now input 2a in this once. When we input 2a, now you have to be careful since we're doing everything manually, you have to be careful that you are not making any sign errors anywhere. If you use this, you would end up getting a negative area. Yes. So if you put that equal to 9 over 16, you will not be able to find values of a. You'll have to put that equal to negative 9 over 16 then, if you decide to do that. But I would not recommend that you do it. That's going to confuse you. Just use the original function. Achha. Now, minus 2a cube. Put 2a inside brackets, whole cube, divided by 3, plus 3a into 2a whole squared divided by 2 minus 2a squared into 2a. That is what we get when we input x equal to 2a. Subtract from this the case when you input x equal to a, and that will give you minus a cube divided by 3 plus 3a into a squared divided by 2 minus 2a squared into a. That equals 9 over 16. Okay, let's simplify this now. We have to find the value for a, so it's going to require some simplification now. Minus 8a cube. Minus 8a cube over 3. Minus 8a cube over 3. And then, what does this simplify to? 2 and 2 will get cancelled. We have 6 left then. 6 and then a into a squared, that will be a cube. What about this? 4a cube, negative 4a cube. Minus minus, that becomes plus 1 over 3a cube. Minus and plus, that becomes minus 3 over 2a cube. Minus and this minus, that becomes plus, and we have 2a cube. That equals 9 over 16. Now we need to take LCM. What's the LCM of these numbers? This is 3, 3, 2. LCM is 6, right? Let's take LCM on the left side. See what that gives us. It will be 6, right? The LCM. So in the denominator, we've got 6. Now this gets multiplied by 2. So we get minus 16a cube. If we had calculator allowed, we could just put this whole thing on our calculator, right? In place of a, you put 1 and just put the numbers on your calculator. But in this case, we have to do our calculation manually. So this is minus 16a cube plus 6 times 6, that will be 36a cube. We could actually simplify this first a little. That will make things easier maybe, but okay, now let's actually do that. I'll do that. So it becomes slightly more efficient. Let's add these terms. 6 minus 4 plus 2. That will be 4. So we have 4a cube minus 8 over 3 plus 1 over 3. What will that become? Minus 7 over 3. So minus 7 over 3a cube. I'm adding the terms that have the same denominators, right? What about this? This is just minus 3 over 2. On the other side, we've got 9 over 16. And now it will be easier to take LCM now. We have 6 in the denominator. 6 into 4, that's 24. 24a cube minus 7 times 2, that will be 14a cube. 3 times 3, that will be minus 9a cube. On the other side, you've got 9 over 16. In the numerator, what we're getting here is, let's do some simplification here as well. We've got 3 left here, 8 on the other side. In the numerator, what are we getting? 24 minus 14, that's 10. 10 minus 9 is 1. So we have 1 over 3 a cube, that is equal to 9 over 8. And that gives us a cube equal to 27 over 8. Take cube root on both sides. Cube root of 27 is 3, cube root of 8 is 2. And that's the value of a that we were looking for. Okay, so the concept was not that difficult, but the algebra, it took some time. And that's how you would do it. Is that okay? Okay. That was question number 11. That was a 6-mark question. Now we've got an 8-mark question. And that's the last one, yeah. Question number 12, let's do this. Question number 12. So now they're saying find the coordinates of the points of intersection of the circles with these two equations. Points of intersection of these two circles. Acha. Now, whenever you have equation of a circle, remember what will happen would be the coefficients of x squared and y squared, they will always be the same. Coefficients of x squared and y squared in one equation, they will always be the same. Otherwise, it would not be a circle, it will become an oval. So in case of a circle, these coefficients will always be the same. Similarly, in the other equation as well, they will be the same as well. Mostly they will be 1 already. If they are not 1, you can make them 1 yourself. In this case, they are 1, so we can, just use it as it is. The idea is, if you try to do substitution here, that is going to make things very complicated, right? Because you'll have to complete the square first for this. And then once you complete the square, when you try to make y or x the subject, you will end up getting plus minus there as well. So that will complicate things a lot. In problems like these, where you have to find points of intersection of two circles, what you can do is you can just equate the two circle equations like this. X squared, just make sure in both of them, the coefficients of x squared and y squared are first of all made equal to each other. Generally, they will already be equal. But if, for example, this equation was multiplied by 2 and you had 2x squared minus 24x plus 2y squared minus 12y plus 40 equal to 0, before you do the next step that I'm just going to tell you about, you will divide this equation by 2 so that the coefficients of x squared and y squared, they become 1. So make those coefficients 1 first of all. Once you have done that, now this is equal to 0, this is equal to 0. We can say their left hand sides are going to be equal to each other as well. X squared plus 2x plus y squared minus 4y minus 20. That should equal x squared minus 12x. When we find points of intersection, we have to solve equations simultaneously, right? That's what we're trying to do. We get something like this. Now, generally, this would not be a very good idea. Generally speaking, it's not a very good idea to do something like this when you have to solve simultaneous equations. So for example, if I had an equation like this, 5x plus 2y minus 7 equal to 0, and maybe 10x plus, I'm just writing random equations, 10x plus 2y plus 3 equal to 0. Now both of them are equal to 0. It would not be a good idea that you do 5x plus 2y minus 7 equals 10x plus 2y plus 3. That's mathematically correct, but that is not going to give you anything useful, right? You still have an equation in terms of x and y. You already had them before as well, so it's not going to make things any simpler. But in case of equation of a circle, when you do something like this, like we are doing here, what would happen would be x squared, y squared, x squared, y squared, they would get cancelled on both sides. They would get cancelled. And that will give you a much simpler equation. You'll end up with a much simpler equation like this. 2x minus 4y minus 20. That is equal to minus 12x minus 6y plus 20. Now that's an equation that only has x and y in it. It only has x and y in it. Okay? Now you could simplify this a little, take all y terms to one side. Maybe let's make y the subject in this. I get 2y. On the other side, I have minus 14x and minus plus 40. Plus 40, right? So I brought this on the left side. That gave me 2y. 2x on the other side, that's minus 14x plus 40. Now, what's the value of y going to be? Y is equal to minus 7x plus 20. Now, you see, that one single step, that gave us this nice equation without x squared and y squared. And now we can substitute this in any one of those two equations. Substitute this in any one of those two equations, you'll get a quadratic equation, solve that quadratic. You can put this here, you can put this here in any one of them. Let's do that. If I put this in the first equation, x squared plus 2x plus y squared, you could do completing square method as well, but that's going to make things more complicated. This is much more efficient than that. When you're finding points of intersection of two circles, it's more efficient to do it directly like this without completing the square. Achha, minus 4y minus 20 equal to 0. Let's input this equation in this. Put y equal to minus 7x plus 20 in this. Now, what do we get? We get x squared plus 2x plus minus 7x plus 20 whole squared minus 4 into minus 7x plus 20 minus 4 equal to minus 20 equal to 0. Now, by this time, when you reach the end of the paper, the probability of making careless mistakes also increases. So you have to make sure that you are very focused. I'll just check my working again. X squared plus 2x plus minus 7x plus 20 whole squared minus 4 into minus 7 20 minus 20. Looks okay. Let's simplify this. X squared plus 2x plus, let's simplify this. This is a minus b whole squared, right? It will become 49x squared minus 7 into 2. 7 into 2 is 14. 14 into 20. 14 into 20, 14 times 10 is 140. Multiply that by 2, that will become 280. So 280x plus 20 squared, that is 400. Minus 4 into minus 7x, that will become 28x minus 80 minus 20 equal to 0. Simplify this. X squared plus 2x plus 49x squared minus 280x plus 400 plus 28x minus 100 equals 0. Now the x squared terms give us 50x squared. Then the x terms 2x minus 280. Let's add the positive terms first. 2x and 28x, that's 30. 30 minus 280, that's minus 250. So we have minus 250x. Then the constant terms 400 and minus 100, that will become plus 300. Now all terms are multiples of 50. So that gives us x squared minus 5x plus 6 equal to 0. If we divide the whole thing by 50, we can factorize this. X squared minus 3x minus 2x plus 6 equal to 0. We get two factors from this, x minus 3 into x minus 2 equal to 0. There are two possible values of x that we're getting, x equals 3 or x equals 2. Put them back in this equation. Now the linear equation, that will give us two corresponding values of y as well. Let me write that on the side. Y equals minus 7x plus 20. Input this here. Y equals minus 7 into 3 plus 20. Y equals minus 7 into 2 plus 20. This y value is negative 1 minus 21 plus 20, and this y value is 6. They were asking for the coordinates of the points of intersection. What are those coordinates? One point is 3 and negative 1, and the other point is 2 and 6. These are the final results that we end up getting from this. That's our final answer. ठीक है? Is that all right? That was the last question. That completes this paper. There were some tricky questions in this. This last question, if you have not done a question like this before, a lot of people would get stuck at this, trying to make one variable the subject from one equation. But that's a standard process that you can use for something like this. Apart from this, this also had some slightly complicated calculations involved. This was two substitutions. This was okay. This was also slightly above average. This was easy. Kinematics. This integration was slightly tricky. The last part, the previous questions were all straightforward before this. So question 8 onward, there were some slightly complicated questions. The earlier ones were not that difficult. If you change some steps but get the answer right, do we get complete marks? Yes, as long as whatever you're doing is mathematically correct. As long as what you're doing is mathematically correct and you're showing complete working for that, that is acceptable. Any other methods that are not part of your syllabus, if you want to use any of them, like synthetic division, that's not required by the syllabus. But if you know that, you can use that. Sum of roots formulas, product of roots formulas, they're not part of your syllabus. But if you want to use them somewhere, you're allowed to use them. There's no problem with that. Yes, you are supposed to learn those values for sine, cos, tan for paper one. You should remember them. There's an easy way to remember them. Uh, I'll just tell you here quickly. There's a very easy way to remember all of those values. This is sine, let's say, this is cos, and this is tan. Okay, so an easy way to memorize those values is this. There are 5 common values. There are 5 common values. 0 degrees. You can convert them to radians as well, of course, right? 0, 30, 45, 60, 90. For calculator papers, you can find them from your calculator directly. But for non-calculator paper, you should remember these values. How do you remember them? So think of something like this in your head, or just make a table like this. These are 5 common values, 0, 30, 45, 60, 90, that you're supposed to know about. What you do is you write numbers like this: 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 for sine. For the sine function, you do 0, 1, 2, 3, 4. Divide all of those numbers by 4. Divide all of those numbers by 4. And you take square root of them. These are the exact values of sine. Okay? So for numbers from 0, 30, 45, 60, 90, right? For sine function 0, 1, 2, 3, 4, divide by 4 and take square root. These are all sine values. So the first one is just 0, right? This is 1 over 2. This is 1 over under root 2 over 2, or 1 over under root 2. It's the same thing. This one is under root 3 over 2. And the last one is 1. Now, this is all that you need to write down, because once you've written this down, for cos, it's the same values, just in the opposite order. Just in the opposite order, you've got under root 4 over 4, 3 over 4. In fact, I'll write down the final results after simplification. So if I were to simplify these values, for the first one, this evaluates to 0, right? This evaluates to 1 over 2. This evaluates to under root 2 over 2. This to under root 3 over 2. And the last one to 1. For cos, it's just in the opposite direction. The same values in the opposite direction. And they look like this. 1 under root 3 over 2. Under root 2 over 2. 1 over 2. 0. Tan is just sine over cos. Sine over cos. 0 over 1. That is 0. 1 over 2 over under root 3 over 2. That will be 1 over under root 3. Another way to write that is under root 3 over 3. That's the same thing. This over this, that is 1. This over this, that is under root 3. 1 over 0, you can't divide by 0. That's undefined. The last value is undefined. Right? That's how you can remember those values. Okay. Anav, I'm really not sure what you mean by that. If somebody else understands Anav's question, can you maybe explain it to me? Minusing the powers as the bases are equal. Achha. So first of all, tell me which question you're referring to. Is it this question? 10 part B, is that what you're referring to? I'm not sure what you mean by exponential law because I don't think that's a standard term, exponential law. Let me just search for that. Maybe there's something that I'm not able to match with a law. Acha, indices rules. Indices rule, that's what you're talking about. Acha. Indices rules? Okay. And use indices rules to what? When the bases are equal? Yeah, so we can use them, but where exactly? Where will it make things any simpler? Where exactly it is going to make things any simpler? There was nothing being subtracted there, right? There was nothing being subtracted there. So maybe you can tell me the exact question you're talking about. Okay, otherwise, okay, I think that's it for today then. If there are no further questions, I hope this was helpful. This was March 2026, paper 5-2, sorry, paper 1-2 for IGCSE Advanced. These are free advanced past paper sessions that I'm conducting. If you're interested in joining these sessions, you can have a look at the link in the description. It'll be added to the WhatsApp group after that, where I'll be posting the timings of these sessions because they're going to be different every day based on my availability. So I'll be posting in the WhatsApp group what the time is going to be and what paper we're going to be doing the next day, inshallah. Okay. Now, the plan for tomorrow and the day after tomorrow, I'm not sure about the time for now. I will let you know about the time in the group. But the plan for tomorrow and the day after tomorrow is tomorrow, what we're doing is in November 2025, paper 1-1 and paper 1-3, and also March 2025, paper 1-2. These are three papers from which we will be doing difficult questions only. We are not going to do this complete papers. Close to the exam now, what we will do is both days we will spend on just doing the difficult questions. Difficult questions from these three papers tomorrow. And then on Sunday, inshallah, we do difficult questions from June 2025, paper 1-1, paper 1-2, paper 1-3. We do difficult questions from these three papers on Sunday, inshallah, along with any other questions that you might have as well. We could do them as well. I'll be posting polls on the WhatsApp group. On the WhatsApp group, I'll be posting some polls in which you will be voting which questions you want me to do in a particular session. Okay, based on those votes, the questions that have the most number of votes from each paper, they will be the ones that we discuss in those live sessions, inshallah. Okay, that's the plan. You'll find a lot of other resources, a lot of other helpful resources in the description below as well, like difficult questions from a number of other earlier past papers. So if you look at the description of this video, difficult questions from other recent past papers from until 2024, you'll find a lot of those videos there. You'll find revision videos. There's another playlist for revision videos there that a lot of students find helpful before their exams. Have a look at that as well. Okay, share the PDFs of those papers. Okay, I'll do that. I'll do that. I'll share the papers. Okay, chale. All the best for your preparation for the next 2 days, inshallah. I'll be there to help you guys as well, inshallah. See you guys tomorrow. Allah Hafiz.